All right, welcome back, everyone. Hope you had a good break. The exams, I did grade them. I did post the grades. I still have a few students who need to take the exam, so I don't want to say anything about the exam about whether or not there's a curve or anything like that until I have all the grades in front of me. I see how the class did, as a group, and then what we'll do is we'll discuss those on Wednesday. I'm hoping Wednesday will be nothing but discussion about grades and reviewing for the final. My first thought is that I need to check the syllabus to see how much the percentage of the final is. Let's just say it's 30% because I don't have the syllabus with me, but let's say the finals were 30% and your exams were with 20% each. There is the thought that I would give the final and allow that grade to replace your lowest. In other words, instead of it being a 30% exam, it becomes a 50% exam. Does that make sense? But let's talk about that Wednesday. If you're in the situation, though, where you have one exam that was relatively low, we will have some option as far as how you can work around that, okay? So just FYI. We are going to finish up 9.2 and 9.3 today, so that'll be finishing up law of sines. We'll do law of cosines, and then we'll do a little bit of stuff in 9.4, talking about areas and a couple of alternative formulas that we can use for areas of triangles. Okay? That's our plan. Who's coming in today at 3 o'clock? Take the exam? Anyone coming in at 3? No? I'll have to look back. I only had a few students that were going to take it late. So, all right, let's get going here. If you recall, we had looked at this thing called law of sines. All right, and I'll just jot it down real quick in case you've forgotten. It just said that if we have a triangle, and it didn't matter what kind of triangle it was, as long as it was a triangle that lived on a flat sheet of paper, then if we labeled the angles ABC, and then the sides opposite of those angles, little a, little b, little c, then these ratios would always hold true. And that's what the law of sines said. And then remember, we said we could flip these over, right? We could have little a over sine capital A, little b over sine capital B, little c over sine capital C. And you used, which one you used depended on what you were trying to solve for, right? That's where we had stopped. Okay, we had done a few examples of that. And now what I wanted to do was start with one example to kind of get us refreshed and then show you some kind of strange things that can happen with law of sines where we have to be careful. All right, so let's start out with, let's say we have a triangle. Go back to my notes from last time real quick. Nine 9.2.4 is where we're going to start today. So 9.2.4. Let's say we have a triangle with this information. I give you that A is 3, B is 2, and capital A is equal to 40 degrees. So the instructions here are to try and solve the triangle. What do I mean by solve the triangle? Find all the sides and all the angles. So there are 6 things that you need, right? 3 sides, 3 angles. You're already given half of the information, right? You have two of the sides, one of the angles. So in order for the law of sines to work, we needed to have at least one side in its matching angle, right? I showed you an example at the end of class or we stopped class and then reviewed, but when I had stopped the class on this section, I had shown you there was a time where if like this were capital C right here, we wouldn't be able to do this problem. So we do have what appears to be enough information to use law of sines. Let's list out the things that we're going to need to find. We're going to want capital A, right? Capital B and little c. Those are the three things we're going to want. So, oh wait, hold on. Capital C, capital B, little c. So what do you want to go after first? Sometimes you have to go after one thing in particular. Let's see if that's the case here. Can we try and find capital C? What would we need if we tried to find capital C? What ratio would we use? Sine capital C over little c must be equal to, now what other one are we going to use? The information on B or A? A, because we have all the information for A, don't we? So we go sine 40 degrees over what? 3. Now, can we do this? No, because we have two things we don't know, right? Capital C we don't know and little c. So although this is the correct setup, we can't do it because there's two unknowns here. Got it? So it would not be wise for us to go after capital C first. How about instead we try capital B? So what would be our setup for capital B? Sine capital B over little b. Do we know little b? Yes, 2. Equals, now set up the same ratio for the sine A over A. And now there's only one thing you don't know, right? So what I'll do is try and get the sine B by itself. So I will multiply both sides by 2 here. So I'll multiply left side by 2, the right side by 2. The 2's will cancel on the left. That'll leave me sine B equals, now watch the way I write this, 2 sine 40 degrees over 3. And what I'll need to do is get my calculator out, and I'll need to make sure I'm in degree mode, right? And I'm going to go ahead and do sine of 40 on my calculator first. Okay, so I do sine 40, I get like 0.642787, something like that. I want to multiply that by 2, right? So multiply that by 2 here. And then I get like 1.285575 something. And now I'm going to divide that by 3. Anybody else get 0.42852, something like that? Okay, so what I have here is this. Sine B is equal to 0.428525. The more decimal points you go out, the more accurate your answer is going to be. If you want to go just 3, that's fine. Just realize that your answer will be probably a little off from what I get on when I do it, but I won't penalize you. Just don't round that to like 0.5, all right? Okay, so now what? What this is saying to us is that sine of some angle is 0.428, right? Sine of an angle on the unit circle, sine is the y-coordinate, right? So this is telling me that there's some angle on my unit circle where the y-coordinate is 0.428 something. I have no idea where that is. So what I'm going to do is use my calculator to do the inverse sine to figure out that angle. Now, pay attention to this because this is the subtle part you have to not get tripped up on. Right now, we're saying that on our unit circle, right, our y coordinate must be 0.4 something. So would you agree I'm somewhere like here maybe? Right, the y coordinate and how high that is off the ground is about 0.428, give or take, right? Is that the only place, though, that it could happen? No, it could happen over here also, right? So there looks like there's actually two angles where this could happen. And both of those angles, would you agree, are smaller than 180 degrees? So it could be possible that these both that they could both be angles within a triangle. So I'm going to have to consider both. But first I have to use the calculator to tell me what the heck the angle is. Now, when I use my calculator and I do, arc sine or sine inverse, right? I'm taking this equation, I'm doing the inverse sine on both sides. But when I do the inverse sine, remember my calculator is only going to give me an answer that lives between where and where. What's the restriction on the arc sine? Negative pi over 2 and pi over 2, right? So my calculator, guaranteed, is only going to give me this answer, the one in the first quadrant. It's not aware of this one, because that's what happens when you do inverse, right? It has to restrict it. But we will consider that other quadrant. Understand, we're using the calculator to get the angle, but we are not restricted like the calculator is as far as the domain. Okay, so do your arc sine of the 0.428 blah, 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 and your answer in degrees should be about 25.37, something like that. We'll say 25.37. So it's telling me that my angle B must be 25.37. Make sure you put your degree symbol, right? So the angle there in the first quadrant, right there, this angle right there is 25.37 degrees. So the angle here has to be the same, because what I need to do now is figure out what the angle is for this point, right? So the angle here should be the same measurement as this angle here in the second quadrant. So what I need to know is what's the angle that goes from here all the way to this terminal side. It's 180 minus that 25.37. So now just on your calculator, do 180 minus 25.37, and you get 154.63. So the other option here, this angle, I'll do a different color. The angle that goes from here to here, that angle could be 154.63 degrees. Everyone clear on that? You have to consider both, all right? So we have two different options right now for B, and I'm going to list them out. And I think I'll have to do that on another page. All right, so here we go. I'm at this point. B could be 25.37. Or B could be 154.63. So let's take the 25.37 first, all right? If we know what capital B is, we now know what capital A and capital B are, right? So can't we find capital C? We have two of the angles now of the triangle. So because of this, I know that C must be 180 degrees minus the 25.37 minus, what was it, A was 40? Do you all understand what I'm doing here? I'm saying that all the angles must add up to be 180. So C has to be 180 minus the other two. And what do you get when you do that? Anyone? 114.63 degrees. That seems reasonable, right? All right. So Now, what do we have? If you go back and you look at what we were trying to get, right? So far, we found capital B, we think, right? We found capital C, and now what we need is little c, and we'll be done. Well, we'll be done with this left side, right? We have to look at the right side also. So let's get little c. So for little c, I'm going to use the law of sines again, right? Can I use Pythagorean? We talked about this. Can't use Pythagorean, right? Because it's not a right triangle. So I use c over sine c equals, and I'll use the a over sine a because that's the information I was given in the problem. So little c is what I'm trying to get. Sine of 114.63 degrees must equal a, which was 3, over sine a, which was sine of 40 degrees. And then to solve for c, what I'll do is I'll multiply both sides of the equation by sine of 114.63. So I'm actually physically going to put that right up here next to the 3. And then I'll do it all on my calculator and figure out what happens. So c is equal to 3 sine of 114.63 degrees over sine of 40 degrees. Now, your calculator is going to determine how much of this you can do all at one time, or if you have a more basic calculator, you might have to do each of these and then write them down and then multiply them. It just depends on what you have in your hand. My calculator allows me to do all of these at one time, but I will tell you what each of these are. So when you do the sine 114.63, you should get like 0.909018, something like that. Multiply that times 3. You get 2.727054, so that's the numerator. Then you divide that by sine of 40. I'm getting 4.2425. So how about we just say 4.242. So there's my C, little c. There's my capital C. There's my capital B. So let me summarize over here all the information I have for this case here. I have my angles A, B, and C, and then my sides little a, little b, little c. So I have 40 degrees here, 25.37 here, 114.63 here. We got 4.242 here. A was 3 and B was 2. That's it right there. Everybody agree with that? Now, what did I say you could do to just kind of make sure things make sense with this? That's right. Your largest angle should match the largest side, the longest side of the triangle, and the smallest, in the middle. So the biggest angle I have is 114.63. It goes with the side, I think, 4.242, which is the biggest side, right? And then the next biggest angle is 40, and it goes with 3, which is the next biggest side. And then the smallest angle goes with the smallest side. So that triangle makes sense. Yes? Good question. Now we actually have to go back and reconsider that. So what we did here is we split this into 2 problems. We said, okay, B could be this. If B is this, then here's the scenario. Now what if B is this? All right? And we're going to see right away it can't be. All right? But we have to consider it. The next example, you'll definitely see you have to consider it. All right? Okay, so let's go ahead and look at this. So now we go back up here. We say, okay, let's say B was the 154.63. Then C would have had to have been 180, right? Take away that 154.63, and then take away the 40 degrees that was A. right? So C must be 180 minus B minus A. And what's wrong here? It gives you a negative angle, right? And when we're looking at a triangle, we consider all the angles to be positive, right? Inside of a triangle, they're all positive angles. So this is not possible. In other words, the sum of the angles is more than 180, which can't be the case. So what does that mean? This was not possible, because this is negative. No, we don't like that. All right? All right, now let's look at a problem where, I'm going to kind of give it away right now, but let's look at a problem where we have a triangle. I give you the information. We come up with two cases, but it turns out they both work. And then what does that mean? All right? So let's look at this. What if we have a triangle where I give you A is 6, B is 8, and then capital A is 35 degrees. So we're going to want to find, well, I should say solve this, right? Solve the triangle. That's what I'll say on the test. Like on the final, I'll just say, give you information, I'll say solve the triangle. So we will want to find here capital B, capital C, little c. So what would you like to go for first? Yeah, B, capital B, right? Because we have little b. We have all the information about A, right? We have little a and capital A. So let's go after capital B first. So to do that, we'll write sine B over little b, which for us is 8, equals sine A, so sine 35, over little a, which is 6. I can multiply both sides by 8. And then I'll compute that. By the way, I'll just mention to everyone that if you emailed me this weekend and I didn't reply, it's only because I just, I forgot my laptop at work, and we were having issues at home with our computer. So I haven't checked my email. I have like over 80 emails waiting for me when I get back to my office today. So if you did, sorry. I got them on my phone, but I don't like going through emails on my phone. So, all right, so let's see. Y'all got that yet? 8, 5, 9, 9. What are you getting? For sine B, we won't do the inverse sine yet, but what do you get there? Yes, I got the same thing, 0.76, let's say 5. How about that? Good? 0.765. So again, this goes back to that same picture, right? This is saying that we have a circle. Somewhere on that, our y-coordinate is 0.765, right? That's what it's saying. So I draw a little picture here. I know that my y-coordinate is 0.765. That's really kind of close to 1, right? So it looks like my angles are like up here, maybe. There's 2 of them. Agree? Well, they're supposed to be directly across from each other. Sorry, they don't look directly across from each other, do they? There. They still don't, do they? Okay. Now what? Inverse sine on both sides. And you get about what? 49.9 something? 91? Okay, sounds good. All right, so that is a potential candidate for our angle. Well, I guess I exaggerated this a little bit too much because that doesn't look like 49 degrees, does it? But that's what the calculator is telling me it is, so I'm going with the calculator. It's 49 degrees right here. 49.91 is this. Okay. What about the other angle? Yep, you subtract it from 180, just like we did before. And all of these law of sine problems will always work out. You'll have always work out the same way. You'll always have that picture. You'll always be in the first two quadrants like that. You'll always be subtracting that angle from 180. That'll always be the case for law of sines. Yes? Because on the unit circle, when I said, if I said sine of theta is 1/2, you went to the unit circle and you looked at the y coordinate and you said, when is it 1/2, right? And weren't there two places where that happened? Same thing here, except instead of saying sine of theta equals 1/2, I'm saying sine of theta, well, 1/2 is 0.5, right? So instead of saying sine of theta is 0.5, I'm saying sine of theta is 0.765. You don't know where that is on the circle. So this tells you, your calculator tells you what that angle is. And then you know there has to be another one on the other side. That's right, because sine y coordinate positive means up, yes. Everyone make that connection? Yes? Okay, so now the other angle would be, so I'll put or, B could be 180 minus the 49.91 degrees, right? And let's just round two decimal places. 130.09 degrees. Which again is reasonable, right? It's within 180 degrees. So we now go and look at our two different scenarios. Y'all with me? And I'll do it on the next page because I'm not going to have enough room for this. So B is going to be 49.91 degrees, or possibly B could be 130.01 degrees. And now let's consider both. So what do I do for the first one, 49.91? What's the first thing I should go after now? Capital C, right? Capital C should be 180 minus the other two angles. So C should be 180 minus B minus A. I didn't write that earlier, but that's what I'm doing. So 180 minus 49.91 degrees minus A, which was 35 degrees. So C must be, what is it? 95.09 degrees. So now I have B. I have a potential candidate for C here. And all that's left is little c. Yes? 130.09. Thank you. Okay, so I've got capital B, capital C. I still need little c, right? So I put in my little c here over sine of capital C, which I just found 95.09, must equal, I'm going to use the A information, right? Little a was 6 over sine 35. I isolate little c by multiplying both sides by sine of 95.09 and divide through by the sine 35. And I get, or you get, I should say, 10.42. Sounds good. So I have capital B, capital C, little c, right? And let me put all the information together because I want to check to make sure that it matches up as far as biggest side, smallest side thing. So I'm going to write them all down. Capital A, capital B, capital C, little a, little b, little c. Capital A was 35 degrees. Capital B, I found was 49.91 degrees. And then this one was 95, capital C was 95.09 degrees. Little a was 6, little b was 8, right? It was given to us. And little c we found to be 10.42. Does that seem to all be within specs, right? Biggest side with biggest angle? Yeah? We happy with that? Okay. How would you all like to have a quiz grade where you just tear out a sheet of paper right now and you do this other side? You don't want that as a quiz grade? All right. Put your name on a piece of paper. I don't want you to rewrite the whole problem. Just assuming the rest of the information is there, just figure out the rest of B for me. So figure out what capital C is and little c is. And I'll even leave this up here. You can use your notes just so we have a nice quiz grade instead of just like an attendance grade. When you're done, please just bring it up. you all get? What is it for capital C? Tell me if this sounds right here. 14.91? Sound right? Okay. And then for little c, did you get like 2.69? Okay. I won't go through the work. Let's just say that's right. All right. So if we summarize everything now, capital A, capital B, well, you know, I'll bring it down here so we can compare them. Capital A, capital B, capital C, we have 35. This time we have 130.09 and then 14.91, little a, little b, little c, 2.69, 8, and 6. And those do match also, right? We do get the largest angle with the largest side, smallest angle, smallest side. So what do you think this tells us? I mean, we have two different triangles, don't we? These are not the same triangle. They do have some similarities. I mean, they both have an angle 35. Both of them have some angle 35, where the side opposite of it is 6. They both have a side of it that's 8. But then other than that, the other angles and sides are different, right? So it means that if we draw this, there's actually two ways to draw it where it satisfies the given conditions. So let me show you what we mean. Let me do it this way. Okay, so let me try and draw this. Let's say, draw this side, I call that 8. And then this side over here, I'm going to call this side, this is going to be my C. So I'm going to make it 2.69. And then coming up like this, that will be my 6. And let's just look at what these angles are here. Remember that the 8 was B, the 6 was A, and this side was C. So do you agree right now this looks like this one over here on the right? Now let's just check the angles. For side B, I have 130.09 degrees. Does that look like 130 degrees, roughly? Yeah. It's a kind of a bad drawing, sorry. And then this side, what would this angle over here be? A, so that's 35 degrees. And then the angle up here was what? 14.91 degrees. All right, now watch. I'm going to highlight the things that I am not allowed to change. In the problem, they gave me what B was, right? They also gave me this angle 35, and they told me that the side opposite over here had to be 6, correct? So I'm going to draw another triangle that's going to satisfy all those conditions. This time it's this side over here. This is going to be 6. I don't like that. So all I've done is I've taken this side 6 right here, right? And I've swung it out over here like this. Do you see that? And when I do that, again, it's not a very good picture. If I were to connect this together like that, I have a new triangle, don't I? And now what's happened is that this angle that used to be 130 is now this angle, right? Which is what? The 49 degrees. So that's a 49 degree angle. This side C, instead of being 2.69, is actually what? 10.42. Do you see that? So the point of this is that if you get to that point where you do inverse sine and you get two angles and they both work out, then there's two possible triangles. Understand? So we've seen the previous example to this. We got two different values for the inverse sine. We got two different values. One of them didn't work, the other one did, right? So there's only one triangle possible. This one, two possible angles. They both gave us good triangles, so there's two possible triangles with that given information. And now let's look at the last situation that we could encounter, which would be something like this. Don't know why that's... Okay, so how about this? 9.... What are we on? 2.26. What if I give you information like this? I say, all right, draw me a triangle. Give me all the information of a triangle that's A is 2, C is 1, capital C is 50. So if I asked you to solve this, what would you go after first? Big A, right? So I'll write down sine capital A over little a is equal to sine capital C, which is 50 degrees, over little c, which is 1. Oh, sorry, little a was 2. Should have put 2 there. Then multiply both sides by 2, so sine capital A is equal to 2 sine 50 over 1. Anything over 1 is itself, right? And what is 2 times sine 50 on your calculator? $1.532, something like that, right? You with me? Now, what's wrong with that? What? When you do arc sine on your calculator, it says what? Error. Okay, why though? That's right. Remember what, we can look at this two ways. Let's look at it both ways. This is saying sine of an angle is 1.53. That means on my unit circle, right? Unit circle, I want to know where the y-coordinate is 1.53. But remember, the unit circle, when I say unit circle, what's the maximum distance I can have out from the origin to the edge is maximum of 1, right? Unit means 1. So it's saying, when is your y-coordinate 1.53? You cannot be on this unit circle with a 1.53. Does that make sense? The other way to look at it is just to look at the sine A as being a sine function, the graph of sine. The graph of sine looks like this, right? What's the amplitude? What is the amplitude of this one right here? Well, it's the number in front of sine, which is 1, right? So the highest it can be is 1. So there's no way this is ever going to happen. Or you just do it on a calculator and get error, but I want you to understand why. So this is not possible, right? Not possible. Which means there is no solution. Which means it is impossible for me to draw a triangle that satisfies these conditions. I cannot draw something that has side A of 2 with side C1 and then having an angle on C being 50. It's just impossible. You could try it yourself, but I mean, think about what's happening here. If side A is 2 and side C is 1, then the angle for 2 has to be bigger than this angle for C, right? So this has got to be bigger than 50, right? And so let's say it's, I don't know, 60. Then you add them together, you'll be at 110. That only leaves you 70 degrees, right? And no matter how you do it, you can't draw a triangle that's going to satisfy this. So the only way to really try it is to get out a ruler and a protractor and try and draw something like this. You know, measure the angle, try and draw the sides. You're just not going to be able to do it. Okay, so that's it with triangles, right? so far, we've seen there's 3 possibilities. So I'll kind of summarize 9.27. In summary, given info on a triangle, we could have one solution. So what we mean by one solution is a unique triangle. Only one way to do it, right? One triangle possible. The other thing that could happen, we could have 2 solutions, right? 2 triangles. And then what did we just see the third possibility could be? No solution. Not possible to draw a triangle in this manner. So on your final, if I'm going to give you a test that's going to include law of sines, I probably will give you one that has, one for each of these scenarios. 1 solution, 2 solutions, no solution. So that way you know when you're faced with those what to do. We good? Okay, I would like to do one application of this. Let me go back to, we had a review. Let me see if I can find my review. No. That's not the one. I'll just give you one. It was something like this. It was similar to this. Let's say that we have a building that we want to figure out how high it is, how tall it is. Okay, so we've got the ground here. We've got this huge building. Skyscraper. Let's say we stand on the ground and we measure with some sort of device, we measure the angle from us up to the top of the building. And let's say we measure that to be 26 degrees, right? And then what we do is we walk from here to another point, let's say here, and we're able to measure that distance, right? We're able to measure this distance. Let's say we walk 25 feet. We measure again, and now we get another angle here. This time, it's 47 degrees. Now, I'm making up this problem, so I don't know how tall this building is going to wind up being because I'm totally making this up. All right? But you get the idea, right? Now, in the past, we were able to solve this problem without the law of sines. But it was a pain in the ass to do it. All right? It required quite a bit of work. Do y'all remember doing a problem like this? It was on a review for something. I remember giving it to you, and I never tested you on it. But this would now become a test problem because it's much easier with law of sines than it was earlier in the semester. So what is it that we're trying to find here? What are we trying to find? The height of the building, right? Let's just call that H. Right there, H. So how can we do this? Anyone have any ideas using law of sines, how we might be able to do this? Okay, so first triangle, let's say you're referring to this one right here. So we have a triangle here. We also have a triangle here, right? We have two triangles. One of them is a right triangle. Do you agree? The green one is a right triangle, but the yellow one is not. Yes? So tell me if you agree with this. If I knew this distance on the ground, right? If I knew the distance here, right? If I knew this right here, then I would have an angle, the adjacent side, correct? And the opposite side of 47. So I would know that tangent of 47 would be h divided by this side, correct? And I'd be able to solve for h if I knew that base. Likewise, if I had the hypotenuse, right, this green hypotenuse, then I would have the angle, the opposite side, and the hypotenuse, right? Which means I could say that sine of 47 was h over this, and I could solve for h. So what I'm getting at is that it would be great to either have the adjacent side of this triangle or the hypotenuse of the green. Do you agree? If I had one of those, this problem would work out pretty nice. Understand or not? Okay, but it used to be hard to get this hypotenuse because we didn't have law of sines. My question to you is, can we solve for this side, which is the hypotenuse? Well, it's also part of this yellow triangle. So the question becomes, can you solve the yellow triangle? If you can solve the yellow triangle, you'll have the hypotenuse, won't you? So let's label some stuff here. Let's label the side down here little what? I don't care. Just don't say h because we're already using h. We'll call this side right here what? Little a. Okay, little a. So little a is 25. That forces this top angle up here to be called what? Big A. Okay. All right, now this angle here, I need to call it something. 26 degrees, let's call it capital B. We can't use A though, right? Because we already have A. This capital B, which forces this angle right here to be called what? Capital C. Which forces this side over here to be what? Little c. And then what about this side right here? Big, little b, right? Do y'all see my triangle I've drawn here? So what is it in this big picture of things, what is it that we actually want to find? I mean, what do I want out of that yellow triangle? What's the one piece of information that I think is going to be most useful to me? Little B or C? Little b, because little b is the hypotenuse of the yellow, right? That's the one I want? Let's see if y'all really understand that. What I'm saying is that with this green triangle, tell me if I could write this right now. Sine of 47 degrees equals h over b. Do you agree with that? Sine of 47, here's 47 degrees. Sine is, because it's a right triangle, right? That's the key. The yellow one is, the green one is a right triangle. So because of that, sine of 47 is h over b. If I knew what b was, like if it was 10, then I would multiply both sides by 10, and wouldn't I have h? So the thing that I want is to figure out what little b is. If I know what little b is, I'm in business. Yes? Okay, so how are you going to find little b? Well, I have capital B, don't I? I have big C? Okay, so the fact that if we rotate from here to here is 47, and I know that all the way is what? 180, then I know that C plus 47 must add up to be 180, which means they're supplementary angles. So I'm gonna find capital C now. Capital C should be equal to 180 minus 47, which is what? 133. I also have big A, right? Big A, because I have now two of the angles of the triangle, I can get the third. So that implies that capital A must be 180. Take away the 133 we just got. Take away the 47. No, not 47. 26. And what would that give you for little a? I mean, capital A. 21 degrees. Everybody see that? So what I'm going to do is I'm going to take a moment real quick. I'm going to draw this triangle out just so we all see it. I have 20, that's not big enough. Let me go bigger with that. This is my yellow triangle. I have 25 feet here, which was little a. I have B is 26 degrees. I have C is 133. And I have capital A is 21 degrees. And what is it that I'm trying to find? Little b. Well, I'm trying to find little b. I have capital B. I also have little a and capital A, don't I? So we're going to set up a ratio to get little b. So what law of sines one should I use here? Which one? If I'm trying to find little b, so I could use sine A over A is equal to sine B over B, right? But remember I said that it didn't matter, you could flip them? I'm going to flip them because I'm trying to solve for little b, right? So I'm using this one now. I'm going to use little b over sine capital B must be little a over sine capital A. Understand why I'm doing that one instead? I mean, just because the little b is there, right? I don't have to remove it from the denominator. It's already sitting there waiting for me. So let's fill this all in. Little b over sine capital B. We said capital B was 26, right? Must equal little a, which was 25, over sine of capital A. Capital A was 21. Solving for B, I get 25 sine of 26 over sine of 21. So get on your calculator and do this. Anybody else get 30.58? Yes? So B is 30.58 feet, right? Are we done? No. Now we go back up to the whole reason we did all this. We did all this because we knew that way up here, because on the green triangle, sine of 47 was h over b. And now I know what b is, right? So I'll write that down on the next page. Now, using the fact that sine of 47 degrees must be the height of the building over b, we get sine of 47 degrees must be the height of the building over 30.58. And now multiply both sides by 30.58, and you should get your height. It's not a very tall building. .36. 22.36 feet equals the height of the building. Make sense? Any questions? All right. Let's look at the next section then. Next section is 9.3, law of cosines. So let's just remember that in order for us to use law of sines, we had to have information on at least one side and its corresponding angle. So we needed to know little a and capital A, or little b and capital B, or little c and capital C, right? We had to have that, at least one of those connections. But what if we have something like this? What if I give you little a is 2, little b is 3, and C is 60 degrees. Is everyone clear that you cannot use law of sines here? Is that clear with everyone? You cannot set it up. I don't care how you do it, right? If you need capital A, you're going to need to know something about everything about B or everything about C, but you don't. If you want to find capital B, you need to know everything about A or everything about C, which you don't. Understand? So because of this, we needed to come up with a different formula that would work in this scenario, and that is what law of cosines is. So right here, question mark, can't solve with law of sines. So let me give you what law of cosines is. And it's one of those formulas that I will allow you to write the law of cosines on your formula sheet. Law of sines, I would expect for you to memorize, but you can, I let you write things on sheets anyway, right? On one sheet for the test. So you can put law of cosines and sines on there, but I recommend you just memorize law of sines. It's a simple ratio. If you can just remember that, you'll be good. All right, so here we go. Law of cosines. See if I can remember it. It says if you're given a triangle, again, A, B, C, little a, little c, little b. So we still have to have that same triangle. It's not necessarily a right triangle, right? Then here is another relationship between the sides. The other relationship we have, the law of cosine says, a squared must be equal to b squared plus c squared minus 2bc times cosine capital A. See. So take a look at what this says. All I need to do in order to find little a is to know what b and c are, right? Little b and little c. And I also need to know what? Capital A. Do you see that? I have one angle, and I have the other two sides, and I can figure out what A is. Which is kind of like what we have up here, right? Well, not really, but do you have two sides and then a different angle? That's kind of what this is saying, right? I have two sides, B and C, and the other side's angle. And then I can figure out that other side. So because of this, there are actually three different versions of law of cosines. There's one that you have A squared over here, there's one that you have B squared, and the one that you have C squared. They're all the same, though. It's just switching A, B, and C around. So let me give you the other two. This one would be B squared is A squared plus C squared minus 2AC times cosine, this time, of capital B. So if I know little a and little c, and I know capital B, then I can find little b. And the last one is c squared equals a squared plus b squared minus 2ab times cosine c. So there are your three equivalent forms of law of cosines. Let's do one problem. Let's do the problem we had before. Okay, let's do this one. And then I want to show you there's some other things we have to that we can do with the law of cosines. So let's go back to this problem here. So now let's solve this. So we first recognize law of sines is out the window, right? And now let's go and try and find little, what do we want to go after? Little c? Let's go after little c, all right? So here's what I've got. I know that little c squared must equal a squared plus b squared minus 2ab times cosine of 60 degrees. Yes? Sorry, cosine of capital C. That's the law of cosines written out exactly the way it is. This is going to allow me to try and figure out, well, not what c is, but what c squared is, right? And then I'll just take the square root at the end and I'll be happy. So now, let's just plug things in. C squared must equal a squared. So what's a here? 2. So 2 squared times, or sorry, not times, plus b squared, which is 3 squared, minus 2 times a, which is 2, times b, which is 3, times cosine of 60 degrees. So all I've done is just replaced my a with a, right? My a with 2, my b with 3, and my capital C with 60. And now I'm just going to figure out what all this is. Just remember order of operations, right? Order of operations, parentheses, exponents, right? Multiplication, division from left to right, addition, subtraction from left to right. So I'll do all my exponents first. I'm going to get 4 here plus 9. And then this is all multiplication in here, right? All this is multiplication. So what would you get if you multiply all this together? 4, 12, right? So minus 12, yes? So I have minus 12 times, what's cosine of 60 degrees? You actually don't need your calculator for that, right? 60 degrees is one of common angles. Cosine is which coordinate? X coordinate. What's the x coordinate at 60 degrees? 1/2. Everyone good with this? So I'm going to put together the 12 times 1/2 first to give me 6, right? I'm not going to do 9 minus 12. So I have 4 plus 9 minus 6 is c squared. 4 plus 9, right? I do addition, subtraction, left to right. So 4 plus 9 is 13. Take away 6. What do I got? 7. C squared is 7. So take the square root on both sides. C must be plus or minus the square root of 7. Now, why am I not putting the minus? It's the side of a triangle, right? So it's going to be positive. So C is root 7. Y'all good with that? So up here at the information I'm given, right, I'm just going to throw up here that I just determined now that little c is equal to root 7. Now, we have not solved the triangle, have we? We still need to find what? Capital A, capital B, right? However, don't we now have all of the information we need about C? So what can you now resort back to? Law of sines. And that's what we usually do. We use law of cosines just to get us that one piece of information we need, and then we go back to law of sines. Because people might, I don't know if you would agree with this or not, but sometimes people do not like messing with the law of cosines because there's a lot of room for error in here. Squaring things, subtracting, and then, I mean, sometimes people mess it up. So also, let me ask you this. How would you find capital A from a formula like this? Right? Does one of the law of cosines have a capital A in it? Right here, right? But it's not solved for capital A, is it? So that's the other thing I want to show you in a minute, is how we can still use this to get capital A, capital B, and capital C, but what I'm going to do is write down 3 new versions of the law of cosines. All of them solved for these 3. But let's get to that after another example, all right? That was the only example I had. Oh, can I just leave this problem to you to finish? Or do you want me to take this? You think you can get it? Yes? So I'll just put here, now use law of sines. To finish. So if I were doing this, I would have done this next. Sine capital A over little a equals sine of 60 degrees over root 7. That would have been my next step, because I would have wanted to know what capital A is. So I would have set up the law of sines ratio using all the information for C over here. And once I know what capital A is, what? Should be easy to get capital B, right? Because I'll have 2 of the angles. And to get the third, I just make sure they add up to 180. Okay, 9.34. What if we have something like this? A equals 4, B equals 3, C equals 6. Solve the triangle. And this is it. This is the last scenario we're going to look at for triangles. I have not given you one like this yet. But after this one, you will have been shown every possible scenario for triangles. I've given you nothing but sides, right? Given you no information on angles, and I want all the angles. Can you use law of sines here? No, because you have to have at least one angle, right, for law of sines? At least one. Or you have to have the information, all the information about either A or B or C, which you don't. Okay, now when you look at law of cosines, it allows you to solve for A squared, B squared, or C squared, right? I already know what A squared, B squared, and C squared is, right? So what I'd like for you to notice is that, let's just take that first, what was the first version I gave you for law of cosines? A squared, okay, I'm just going to take that first one right there. Notice that when I gave you this, that was the first version of law of cosines. I would like to see if it is possible to get that by itself. Can you get that by itself? To BC, yes, thank you, BC. Change that right there, that's B. So get this by itself. This stuff right here is attached to this by multiplication, right? So I don't want to touch that yet. Can I get the B squared and the C squared to the other side? Yes, subtract each of them. I subtract B squared, I subtract C squared, I get this. A squared minus B squared minus C squared equals -2 BC cosine A. Y'all okay with that? Now, I'm trying to get that cosine A by itself. So I would like to divide both sides by negative 2bc, right? Because this is all multiplication here. Let's divide it through. So if I divide this side by negative 2bc, and divide this side by negative 2bc, everything goes away on the right. I'll be left with the cosine A. On the left side, I'll have this, right? And do you all remember someone telling you ever that if you have a negative on a fraction, that the negative can be on the bottom or on the top or out front? I'm going to take the negative 2 down here because I don't like the negative on the 2. I don't know why, we just don't. I'm going to move it to the top instead. So won't that change the signs of everything up here? It'll make this a squared negative a squared. It'll make the negative b squared positive b squared. It'll make the negative c squared positive c squared. Yes? So watch the way I rewrite this. This is going to become cosine A equals c squared plus b squared minus a squared over bc. 2bc. I don't know what you saw. There was a 2 there. 2bc. So the negative came off the bottom and changed the signs of everything on top, so I rearranged the order. And then I moved the cosine A to the left. I just swapped, the equality doesn't matter which way you write it. So this is a new formula. But this is still law of cosines, all right? It's just a different version of law of cosines because now what it's done is it's isolated that angle, hasn't it? As opposed to up here where it isolated the side. So I could find little a if I had all this information. This one says I can find big A if I know what? Little c, little b, little a, right? If I know all the sides, I can find the angle for A. Yes? Would you agree that there are probably 2 more formulas just like this? There's one for cosine B. There's one for cosine C, which I'm not going to write down. Just let you figure those out yourself, all right? I don't even think the book does it. Yeah, the book doesn't even give you that formula, like that one right there, okay? They just assume you can move things around yourself. So let's go back to this now. I said notice this. Let's go try and figure out this triangle, all right? So A is 4, B is 3, C is 6. So what would you like to find? We can find any of the angles. How about capital A? Because I just wrote a formula down for capital A, right? Well, for cosine of capital A. We know that cosine of capital A should be equal to c squared plus b squared minus a squared all over 2 times what? BC? Do you agree that that's just me plugging in ABC into the formula? Okay. With my calculator, cosine capital A, I'm doing 36 minus 9 minus 16, plus 9 minus 16, all over 36. Hey, can I cancel those 36s? No, don't do that. 36 plus 9 minus 16, and then divide that by 36. Anybody getting like 0.8055555 on the right side? Okay, so what I have here is this. Cosine of A must be 0.80555 repeated. I'm just going to say that. We are at a point that we were at in law of sines where we said, okay, we were saying earlier, sine of an angle is a number, and then we drew a circle, didn't we? And we said, okay, it could be 2 different values. But now we're saying what? Cosine of an angle must be this. Cosine of an angle. So tell me about cosine. Cosine is which coordinate? It's the x-coordinate. The x-coordinate must be 0.8. So I don't know, x-coordinate means 0.8 somewhere around here. So the x-coordinate distance, this distance on the x-axis, is about 0.8. Do you agree? Where else could it be? 0.8. In which quadrant? Fourth quadrant, right? Which would be down here. But why don't I care about that? Why am I not going to consider that? That angle is either, you're going to look at it one of two ways. Either the angle is negative, which this is the angle of a triangle, it's not going to be negative, or the angle is what? Coming all the way around? Which is way bigger than 180, right? Which is impossible to have an angle bigger than 180 in a triangle. So do you see with this law of cosines, when I type in inverse cosine on my calculator and do this, the answer I get is the only answer possible. That's it. So that's the good thing about law of cosines when you're using it here, is you don't have to worry about two different scenarios. There's only one. So I'm going to do cosine inverse on both sides. Oh, so scrap that. And the angle I'm getting is like 36.34. Angle A is 36.34 degrees. Yay or nay? Yes? Now what? Law of sines the rest of the way. See, because now you have little a and big A, don't you? So you just go with law of sines the rest of the way. So now law of sines. So like law of sines is like the closer, all right? It comes in and finishes off the problem. We use law of cosines usually just to gain that one extra piece of information we need to use law of sines. Okay? Now, if you like law of cosines, you're free to use it whenever you want. Well, there are situations where law of cosines would not work, right? Like, I could not use this if I had capital A and capital B and just little c. I couldn't use this. I would then be looking at law of sines. But you now have a way of solving any triangle, no matter what. If it's a three-sided on a flat sheet of paper, no matter how it's drawn, no matter what information. Well, they still have to give you some information, but with all the different scenarios, you should be able to solve the triangle. Okay? Questions? We've got about 10 minutes. I want to show you two more things. 935. Actually, this is a different section, so I'm just going to tell you what it is. 9.4 areas of triangles. I just want you to see this, okay? Especially for those of you taking calculus. I'd feel like I'm ripping you off if I don't show this to you. All right, so when it comes to areas of triangles, there's one that most people know. And that's if someone gives you a triangle, and let's just say it looks like that. If you know the height of the triangle and you know the base of the triangle, then the area of the triangle is a measurement of, like, if you had to paint it, how much area, right, it covers. So the area of a triangle is what? Have y'all heard that before? 1/2 base times height? Yes, show of hands. Okay, most people have seen that. Area of a triangle is 1/2 base times height. I'll just show you real quick where that comes from, all right? Because it's pretty simple to show you. Can I show you? Do you mind? It'll take just a second. Okay, why is this formula true? Well, to show you it's true, let me first see if we all agree on this. If I give you a rectangle, I call this the base, different letters. Let's call this the width. Let's call this the height. What's the area of a rectangle? It'd be just side times side, so width times height. Does everyone buy that? Because you have to believe that's true in order for me to prove this to you. Yes? Area of a rectangle is just multiply 2 sides. Okay, so what I'd like to do is I'd like to take this triangle up here that I was trying to convince you the area is 1/2 base times height, and I'd like to draw it again like this. Here it is. I'd like to make a duplicate of it, another copy of it. So I can even have my thing here, copy it, and I'm going to just paste it right here. Here's an exact copy of that. Y'all agree? There's a copy. I thought I could rotate this. Sorry, I thought I could rotate this thing. Rotate. Okay, here we go. I want to rotate it 90. Rotate it 90 again. Okay, now grab it. I'd like to put it right here. Okay? See that? Now what I'd like to do is take a pair of scissors, and I'd like to cut straight up. I'd like to take that piece right there. You see that piece? I'd like to cut it off, and I'd like to place it right here. Do you agree that that would just be gone, and then it would fill in that piece right there? And what have I created now? A rectangle, right? What's the area of this rectangle? Well, if this is the base, right, and this was the height, then wouldn't it just be base times height? But didn't I make a duplicate copy and put them together? So base times height should be 2 of those triangles put together, right? So just one of them would be half of that. If you follow that, great. If you don't, who cares? It's not a big deal. But that's the picture of why this is true. All right? Now that's the traditional formula, and we're happy with that formula, but the problem is that you have to know the height, don't you? And very seldom do we actually know the height of a triangle, unless it's a right triangle. So what we have instead is an alternative formula that is much more powerful in a calculus class. It goes like this. 9.42 area of triangle. So let's say you have a triangle. Can't draw a triangle. Very good one here. Let's say that you know this angle right here. Okay, so I'm going to use a different angle than A and B. Let's just say we have that the angle there is theta. All right? We know that. And we also know this side and this side. So if you have a triangle where you know 2 of the sides and the angle between those 2 sides, here's the formula for the area. The area of this will be 1/2 A times B times sine of theta. AB sine theta is the area of that triangle. Notice that this formula has I have no information about the height, do I? Right? I don't know anything about the height. I just know 2 of its sides and the angle between them. Y'all follow me? Now, where does this come from? I think it's something I can explain relatively easy. Take that triangle. To see if you follow this. I'm going to call this side right here height. And then this side here is B. Right? I want you to see this B here is the same as this B here, right? It's like the base. But this time I have an angle here, and I have this side over here, A. Can somebody tell me what the relationship between theta, H, and A is? And I'll give you a hint. This is a right triangle, isn't it? Right here? This little triangle right here is right. What's the relationship? Sine of theta is what? Is H over A? Agreed? So what's H? Multiply both sides by what? A. So A sine theta is H, isn't it? So what did we say the area of a triangle was? Most of you knew what it was. It was 1/2 base times height, right? But if I replace height with A sine theta, then it's 1/2 base B times height, a sine theta, which is this. So the only difference in the formula is that a sine theta right there is actually the h. Do y'all see it? The b is still the b, the base. So let me show you how you could figure out the area of a triangle with this. Find area. So here's what will happen in a calculus class. We'll get to a problem somewhere where we'll have to find the area of something like that. All right? In fact, we won't have 5, 5, 5. It'll be like x, x, x. And we want to find a formula for the area. But we'll do 5, 5, 5 here. I'll get students that the first thing they'll do is they'll say, okay, well, look, I can create a right, don't write this down. I can create a right triangle, right? And then I can say that that right triangle on the right-hand side like that is 5 here, and then this distance from here to here would be half of 5, wouldn't it? Wouldn't this be halfway? Yes? And so they would say that's 5 over 2, and then they'd use what? A right triangle, a squared plus b squared is c squared, and they go try and find the height. And once they have the height, then they do 1/2 base times height. Y'all follow that logic? And as soon as I see a student doing that, I realize that they did not understand the formula that they got in pre-cal, or they didn't see it. Okay, so this is not the recommended way to do this problem. Do not go after height at all, because you have two sides, don't you, of a triangle? The question is, do you have the angle between them? Well, this is an equilateral triangle, right? All sides are the same, which means all angles are the same. And you have 3 angles, and they have to add up to be 180, which means each one of them has to be 60. So I already know that this is 60 degrees. I already know that, just by the property of an equilateral triangle. So I know that the area of any triangle is 1/2 AB, which for me is what? A is 5, B is 5, and then what? Sine of 60 degrees. What's sine of 60 degrees? Well, what's the y coordinate at 60 degrees? √3 over 2. So this becomes 1/2 times 5 times 5 times √3 over 2, which all comes out to be 25 √3 over 4. That's the area of that triangle. I didn't have to draw, I didn't have to write a right triangle, I didn't have to do Pythagorean, I didn't have to do any of that, right? It was straight away. Understand? We are out of time. There is one more formula in areas that I want to show you. It's called Heron's formula, but I'll just save that for next time. It'll just take us 5-10 minutes. Let me tell you what you should do for homework for law of sines. I recommend that you do off of page 685. Look at probably 17 through 35 odds. And then for some problems to work on that are application-based, 39, 41, 42, '49. These are all like word problems. Okay, and then law of cosines, page 693, we'll do something like 17 through, I won't give you so many in this one, 27 odd, 43, 45, 47. Those are also word problems. All right, we will come back. We'll finish up the areas. We will start talking about the final, all right? And talk about grades. Have a good day. Who's coming in to take tests today? Doing tomorrow? 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 What, at 9? 9? Okay. All right.